Hi people, welcome back. So in this video, I'll give you a puzzle. This one is one of the finest I've got. Beautiful puzzle, a classic, and we learn a concept in this video as well. So let's see what is there for you. Okay, the puzzle goes like this. You multiply 2 by 2 and you got the answer as 3. 2 into 2 gives you 3. That is a puzzle. It's kind of you have to decipher what's hidden beneath these alphabets and a few basic conditions for you. It's like every alphabet it's hiding a number beneath it. Every alphabet is hiding a number beneath it. For example, T is hiding, let's say, 7, or T could hide, let's say, 2. I'm not sure what could be beneath T. And then the next condition goes like one number is hit one number for one alphabet. That is, every alphabet is hiding only one number. For example, let's say if T was hiding, let's say, 7, so this T will also be 7 and this T will also be 7. And the next condition, which is pretty straightforward again, it is no two alphabets they can hide the same number. No two alphabets can hide the same number. Continue with the example. It says, for example, if T is hiding 7, W cannot hide 7. W can be anything but 7. Similarly, O cannot be 7. What I want to say here is that 7 can, if T is for 7, if you somehow you manage to find T is 7, so T could only have 7, and 7 could be only coded as T and nowhere else. So that's pretty much the conditions. So these are the conditions for you to solve this puzzle. TWO, 2 into 2 gives you 3. You have to find what does TWO stand for. Okay, and this is one of the most beautiful puzzles you'll ever see. This one is a classic. Find the number TWO. You can pause the video here. This entire video is dedicated to this puzzle only. Okay, let's proceed with the answer. Before we proceed, I want to tell you a simple concept. We'll go on to prove it as well. And the concept goes like that: for any square, last two digits of square of any number, they are governed by last two digits of squares of numbers between 0 and 25. This is one of the most important concepts you'll see, that last two digits of square of any number, they are governed by last two digits of squares of numbers between 0 and 25. Let me clarify this concept. Let me clarify you with using a few examples. Let me give you a few examples. You'll be more clear with the concept. For example, let's say finding square of 57. We can find it with the help of Vedic math pretty easily. It is 3, 2, 4, 9. So we see 4, 9. Square of 57, it ends with 49, and we see 49 at the end of 7 square. Okay, another example. Let's say we want to find square of 129 square. Square of 129 is, using Vedic math again, square of 29 is 841, 129, 158, and 8 is 166. 16641. 41 again we witnessed. 41 again we witnessed. 41, where do we see 41? At the end of 21 square. 21 square ends in 441. Okay, another example. 89 square, pretty easy. 78, 7921. And 21, where do we see 21? At the end of 11 square. Okay. 273 square, 27 square is 729. 273 26 into 3 plus 7 turns out to be 745. 74529. So we see 29. Where do we see 29? At the end of 23 square. So what do we see here? That all of these numbers, any number, we squared any random number, and we saw and we found out that the last two digits of the square, they were governed by squares of the numbers between 0 and 25. This is valid to any number. We can, of course, we can prove it as well. I want to show want to show it to you as well, that this is possible. We can prove it as well. Let's prove it. Let's say we can write any number in this form: 50a plus minus b. Don't be like baffled by this. What, or like where does this 50a plus minus b has come in? Don't be intrigued by this. I'm writing this with certain intention, of course. Any number can be written in this form, where 50a plus minus b, where a is any integer, 1, 2, 3, 50, 60, minus 1, minus 2, minus 80, anything. A can be any integer. And b, and regarding the limits of b is confined between 0 and 25. When I'm writing this notation, I have certain intentions. I have certain intentions to use it, because it will give us a certain result which is useful for us. Okay, this is any number. When I say any number, for example, let's say you want to make 113 using this notation. 113. I'll use a as 2, and I'll use b as 13, and I'll use the positive sign in between. So 15 to 200 plus 13 is 113. Okay, so we managed to make 113. Okay, let's say I want to make 48. How will I make 48? I'll use a as 1, b as 2, and I'll use a negative sign. 50 minus 2 is 48. Okay, another example, 209. Okay, tell me what could be a. Yes, a is 4, and b is 9. I'll use a plus sign. 200 plus 9 is 209. So using this notation, I can make any number. Okay, let's square it now. N square, squaring it. N square is 50a plus minus b square, and we know that square of a plus or minus b is a square plus b square plus or minus 2ab, depending upon the sign that we'll use here. N square is 2500a square. Doesn't matter if it's plus b or minus b, square of it is plus b square always, and plus minus 2ab. Plus minus 2ab is 2 into 50a plus b is 100ab. So n square is 2500a square plus b square plus minus 100ab. Now let's see the last two digits of n square. What are the last two digits of n square? Last two digits of n square, they are, assuming any value of a, it doesn't really matter what is the value of a, and thus the value of a square. Whenever we multiply a square into 2500, we'll get last two digits as 0, 0, because 2500 ends with 0, 0. So last two digits of this number will always be 0, 0. Similarly, last two digits of this number 100ab, whatever be the value of a or the value of b in 200, last two digits will be 0, 0 again. So that means square of n is governed by square of b. The last two digits of square of n, they are governed by last two digits of square of b, because 0, 0 and 0, 0, they'll add up to 0, 0, and thus last two digits of square of n are governed by last two digits of square of b. And what was the range of b? B was confined between 0 and 25. B was between 0 and 25. So we have proved that whenever we square any number, its last two digits, they are last two digits of square of a number between 0 and 25. Any number in this world and its square is governed by squares of numbers between 0 and 25. That's it. Okay, so now let's come back to the question. We had this question, 2 into 2 giving you 3. Okay, let's observe what all do we have here. Let's observe. First of all, it's a square. First of all, it's a square. We are given that 2 into 2, it's certain number, multiplied twice, multiplied 2 times, which means it's a square. And then let's what are the other observations? We are given that it's a square, all right. Then last two digits of the square, last two digits are EE. We are given that last two digits are EE. Now let's recall how many squares between 0 and 25 they end with two similar digits. How many squares between 0 and 25 they end with two similar digits? Only two I can recall, yes. 0 0 and 4 4. We do not see any square ending with 1 1 or 2 2 or 3 3 or 5 5 6 6 7 7 8 8 9 9. No, only two numbers, only two digits that we see at the end of any square between 0 and 25. They are of 0 0 and 4 4. And 0 0, where do we get the 0 0 from? How do we get 0 0? Is it possible, is it possible in this question to have 0 0 at the end, EE as 0 0? No, it's not possible, because had EE had EE been 0 0, it will mean that O and O are also 0. O and O are also 0, because only 0 and 0 can give you 0 0. So if this, if for this to be true, O and E, they both would be equal. They both would be equal to 0 and 0, which we know is not true, because we were given that one digit is hidden between is hidden beneath only one number, one alphabet. So O and E cannot be same. O and E cannot be same. This is not possible. So we are left with only one possible answer, 4 4. EE could only be 4 4. EE could only be 4 4. And from where do we get 4 4? How do we get 4 4 at the end? We get 4 from, okay, go back to the numbers from 0 to 25. Where do we see 4 4 at the end? We see 4 4 at the end of 12 square. 12 square is 144. We see 4 4 at the end of 12. And next hint that we can see from this is T is of the T. T multiplied by T is giving you T again. This T multiplied by this T is giving you T again. How do you think is it possible? T into T is giving you T. For this to be true, T has to be 1. Otherwise, you can plug in any value. 2 into 2 gives you 4. 7 into 7 gives you something 49. Not possible. Only T, for T into T to be equal to T, T has to be 1. This is another observation that we see. Only observation. T has to be 1. Therefore, this number TWO, should be less than 200, because it starts with 1. It is 100 something. It has to be less than 200. Okay, let's use these hints. So we come out. So we all options did we have? Let me take you back to the observations. First observation was it is a square, and last two digits EE we found out that they were 44. And where do we get 44 from? We get 44 from 12. That means in our notation 50A plus minus B, we have found B, that B is 12, because B, when we put B equal to 12, we get 12 square as 144. So last two digits they become 44. That means B is 12. And the third one was T is 1. Okay, let's proceed. So we have 6 options. Let's see what all 6 options. So we have various options. I'm not saying 6 or how many. Let's see how many options do we have. First option is 50A plus minus B. 50A could be 50 plus minus something, then 100 plus minus something, then 150 plus minus something, then 200 plus minus something, then 250 plus minus something. Let's see all these options. 50 plus minus something will give you a 2-digit number. So I've discarded it. I've not written it down. Next is 100 plus minus something. then it's 150 plus minus something. That something is of course 12. That something is of course 12. 150 plus minus 12, 200 plus minus 12, and so on. So these, have I stopped at 200? Because I know that the number is less than 200. We need not go further than 200. 100 plus minus 2 plus minus 12. 100 minus 12 will give you 88. 100 minus 12 is 88. 100 plus 12 is 112. 150 minus 12 will give you 138. 150 minus plus 12 is 162. 150, 200 minus 12 is 188. 200 plus 12 is 212. So these all are options possible for TWO. TW can be any of these numbers. Any of these numbers. We're not sure which one of these numbers will be TWO. So let's begin with discarding. Okay, we see, let's there's a general observation. Let's assume TWO to be, let's say, 150. Let's assume it to be 150. I'm taking this example because it's an easy example. 150 into TW into TW, 150 into 150, it gives you 22500. 15 square 22500. So we have an important observation here, that 1 multiplied by 1 is giving you 2. 1 and 1 is giving you 2. So what do we observe from here? We observe that the number cannot be more than 150, because as the numbers will increase, as the numbers they'll go beyond 150, as the numbers they'll go beyond 150. 150 into 150, it starts becoming 2. So the numbers they'll have to be, so the numbers, so the whatever the answer is, it'll have to be, it'll be required to be less than 150. So we can discard these options straight away. These are numbers more than 150. So we are left with 3 options, and 88 of course is rejected again, because 88 is a 2-digit number. Our answer is a 3-digit thing. So we're left with 2 options. Either our answer is 112 or 138. How do we choose from these 2 numbers? Okay, 112. We can reject 112 as well. If you can observe it, if you can observe how, because 112 has got 2 digits same, 2 of the digits are same, 1 and 1 is same, which means T and W, they are same. From among TWO, T and W, they are same, 1 and 1, which is again not possible. So we're left with only one option, 138. So our answer is, TWO is 138. That's it. This was it. TWO is 138. Hope you enjoyed the class, and you can come back again for more sleepy classes. Till then, take care. Bye bye.